Hello everyone, we are going to solve a one new problem. Its number is 17 on our website and this description is letter combination of a phone number. So if you guys remember, in these days mostly mobile have a soft keyboard, but before that we have a hardware keyboard. So on that pad, uh, if you remember, we have the alphabets against the digits. So like if you have a 2, you have 3 options. You can write A, B, C. Against 3, you can write D, E, F. So it's like a whole map. It's not given by the in a question, but later we need to use. So I already wrote this to save some time. So we have a map in this case. Every digit has some kind of a string against that. Then there is a one constraint, like 1 is not an input. So one thing is there will be no input which will have a 1 because 1 is have a empty kind of a string. So there is a one example. For example, we got a digit. So in our function basically we have a string of digits. So in this case it's given the 2 3 and the answer which is expected by our algorithm is the combination of all those which we can write. So A, D, A, E, A, F. So basically A, B, C and D, E, F. We need to map these and we need to figure it out all the combinations against this. So that is the question. How to solve this question? So for now, I found two approaches. One is a common approach. Just like you can see, it's a combination. So there is simple recursion or maybe backtracking. It depends how you're going to implement. And the other one is iterative approach. So what we will do both. I will try my best to complete that as fast as we can. So first approach, we can go with the backtracking or recursion. So the most important thing to figure it out the tree. Once you figure it out the tree, everything will be pretty easy. But it's not easy, it's not intuitive if you are doing the recursion questions first time. But if you are doing every day or trying to do a practice or in your job you are writing a lot of recursive code, then it's pretty easy. You will figure it out. Otherwise, do your best, spend time, maybe take 1 hour or maybe more than that, maybe a whole day to figure it out how to make a tree. So we will discuss first the base case. So in case of a base case, the user maybe they give us 9 or 8 or maybe 2. So if I have a 2, the expectation is I should return basically a string A, B, C, a list of strings which is like this A, B, C. So in this case, if the input is 2, I want to make a tree which will go A, B, C because map is around A, B, C. So it's kind of a string. So we have a map against 2 A, B, C. So this is the first thing. If I have one input, so I can make this type of a tree. And you know, if you have a tree, most probably it's pretty easy to write a function for this. Then we can take the second example also. So if it's given by 2 and 3, which means A, B, C and D, E, F. In this case, the expectation is basically this input A, D, A, E, A, F. And how we can make this? So in this case, we took first character, then the second character, then the third character. In this case, what we can do, if we spend some time here, okay, if I have a and if I try to start a new tree, and I can see most probably that is kind of a multiplying by this. So AD, then AE, then AF. Just like we can see in the answer, the all combinations. So I will try to make this tree. So first is again same the base, the one input one. So we will have A, B, C. By the way, I'm writing from the human perspective, but machine will do only one thing first, the left side, and then go into the left side. Now what I'm looking for this input. So it's kind of assume there is also D, E, F at every level. And we are moving next to that. So here what I will do, I will say, okay, A is already there. So any the coming from where the recursion started. So it's going down first until, and then it will recover and a backtrack. So for now here it will be AD, AE, AF, and same here BD, BE, BF, and same. So in this case I can see one is a base case. So in this case base case is the input when we have a one character. In this case I have a base case, kind of a not a multiplication, is the appending, but one by one. So I took the first character, then I took the second character, and then I combine both one by one. And I can see also our base case is around the number of characters against the digits. So we can see when I have a one length of a string in a digit, I am returning the answers of 1 1 1. Once I have a two length of a digits, I am returning my answer with the 2 2 2 character strings. And assume this is a 2 3 and 4. So there will be GHI. In that case it will be like ADG, ADH, TGH, and ADI. Same for AB. So only assume if I have an input 2 3 4. So we can see we can create a recursive solution because I can see the same pattern is moving. So for that we can start now writing a code. I hope you understand how I make a tree. So one input, I need this. When I have a two digits, then we can make this, and then three digits like 2 3 4. If it's more, then it will take care of that. And there is also one important part, the 7 and 9. So they are four characters. In this case our tree, for example, I have a 7 and 9 as my digit string. So in this case if I try to make a tree, it will go P, Q, R, S, then it will start from P to W, or I can say okay 7 and 2. So in this case what will happen? PA, PB, PC. So now here you can see the tree is going to be different. Before that we have 3 branches because 3 3. In this case I have 4 branches, then 3 branches. So we will see how to take care of this. Okay, generally we know, once I know for example the 3 branches, so every time for example I have a function from R taking an input, then there will be a base case. If I want to generate the 3 branches, it means I need to call this function 3 times. So it will generate the 3. But in this case I can't go with the 3 hard coded. As I already showed you, there is the edge case with 7 and 9. So in that case loop is our savior, because in this case there should be some input I in 0 until some kind of a maybe s dot size. We will see what will be that. So in this case if I have this 3, it will call 3 times, so there will be 3 branches. And if it's 4, it will generate the 4 branches. So first edge case we are able to figure it out, and we fix by using loop. So there is no hard coded branches the calls. Then next, this is, we are sure okay this is a template, we need to write this. So now we can try first the function, the original function fun maybe f, where we got the digits as string and expecting list of string to return. Here what is the other edge case? If digits is empty, so for now I am writing this. Later we will see maybe our recursion is able to figure it to manage this case. So if it's empty, return empty list. Okay. If this one is not empty, it's time to start our logic. So I need to run that recursion. So first, okay, we will see I'm writing my recursion function. First thing what I need in this function, this digits. So I will send digits. So I will write also here fun recursion R. So I'm saying okay, I will send you digits. So this is our first requirement. What is the second requirement? What I can see, we need to return a list of answers, the list of strings. In this case we have A, B, C. In this case we will have a D, A, E. So for that, now if you are writing code recursion, there are two ways. One way recursion will return you the answers, and the easiest way, you can pass the some kind of a list which will save the answers for you, and in the end you can use that kind of a local, or sometimes people use globally. So I'm saying okay, I will send you the list value which we are saying answers, and it's a mutable list of string. Okay, so answer, and I'm sure, we are sure, we will return this answer in the end. So this is our main function. Now in a recursion, it means I'm sending this answer. So answer's main duty is to save the answers. We will see how, but I hope you understand. So I will add this A, B, C in this. In this case, I will add A, D, A, E, A, F in this answers, and then we will return this answer. In this case, what else I need? So in this case, what else we need? We have A, B, and C, and we remember, once this is going to be called, so this is a base case. There is a base case. I'm not going to play with that. We will see later. But after that, there will be the algorithm which we already know. I can call this 3 times in this case, but we decided to go with the for loop. And in that for loop, how I know, like what I need to send? I need to send these one by one. So first should be, I have a digit 2. I need to get this information. So I will get the, for example, letters, and I will say map dot get, and 2 is our own inner digits of 0, and so this is only a Kotlin thingy. But in this case, we are sure this will never be null if we are here. So map.get will return me the letters, which is means A, B, C. So it's a string like this, A, B, and C. And what I want next, I need to call this 3 times because this is 3. So what I will say, okay, ch in letters, and again I need to call this function R. Okay, digits, answer. Now we need to think, it's time to think about the base case and the value. So basically this A we will save in the in base case. So it means I need to send this information here, ch. So it means there will be a one more string, and which we are going to save. Okay, I'm removing now this and base case. So now we can discuss about the base case. So as we remember, we discussed, this is our base condition, number of length, and length. In this case it's 3, then this 3. So if digits dot length equal to s dot length, it means we are on a base case. I need to save this. In this case, like this ch first time will be A. So I am sending this A, and I need to add this in answer dot add A. Oh, sorry, not A, the string S. Cool. And then return. Or you can write a else, and this code will be in else. Both are saying no need to return, then no need to return. Okay, so First scenario is done. I have a ABC, it will run for A return, then it will run for B return, then C return, and then. Now we'll see what will happen in this case. So we have a 2, 3, digits are 2, 3, it means the length and the string length should be equal to 2. Okay, so first time this will not run. I will come here, I will get 2. So in this case, these letters are A, B, C. Now I will run this again for A. We will be here. In this case, digits dot length is 2, s dot length is 1. So base case is not going to run. It means we need to run our recursion. We will come here and then we will see map dot get digits 0. 0 means 2. So there is a bug now. It's not a bug. Before that we only implemented for first. So in this case, this should be 1. So I can get 3. So in this case, it means I need to take care of the levels. Which level I am, I need to take that digit. So for that, we can send maybe I. So at I need to get this information. So in this case, how to do that? So answer, then string, first time will be empty, and then first time level is 0. So in this case 0, 0, and then here I need to send I plus 1. So every time recursion will automatically increase 0, 1, 2, 3. Okay, so in this case what will happen, we have s of I, then letters. So first time ABC, I run the ABC for A. Now I'm sending 1, it will come here, it will say digits of 1 is 3. So at 3 I will get the DEF. So DEF. And now what will happen, I will say send D. But here we can see there is a bug. So if I send D, I need to append the previous string S plus CH I plus 1. So in this case, I have a D and S is the previous value, which is A. So in this case, I will say A plus D. It's a string, so it will append. Now we have a AD. It will go here, save the AD. Come back. Now still in a previous call, this one I still have A. So A is already S, and then CH will go with the E. So by doing this, this is our final function. So this is a full code and this will work. So now we can execute. I can take the maybe same example. I want to take this example, but it will take a lot of time. But this code should work for all the cases now. So I can say, okay, this is my function f. I'm starting from the R. So I'm calling this R function with, okay, no need to do this, 2, 3. Empty. I'm not taking answer here. Yeah, this string is required and 0. So we started this with a 2, 3. First, no base case. Then I have letters L, which will be A, B, C, because the 0 at 0 we have 2 and 2 map is ABC. Okay, now I have ABC. Now my loop will be called first for A. So once I am calling this for A, 2, 3 is still same. Answer is still, I'm not sending answer, maybe is here because it's an output. I'm not sure if you can see. So this is our answer array. I will write here anything if we need to write. So 23. Now I'm running for A. So A means now I'm sending S. S is an empty plus CH is A. And then index I plus 1, which means now it's last one is 0, it's 1. In this case, still base case is not, because it's 2, length is 2, and as the length is 1. L will get now digit of 1 is 3. 3 against the map is DEF. So we have DEF. Now again there is a for loop. So first I am going to run for D. So we have a call here. In this call, still same. This time, previous, the S is A and CH is D. So AD. and now I'm sending index is 2. So in this case, what will happen? This is true, true. Answer will add A and D, A and D, and then return. So we are going to be return from here. Then this loop is already stopped at D. Now the next one, this one is done. Now we are going to call for E. E call 2, 3, A, E. Again, this is 2. Return from here, and we have A and E. So how it will work? It's like, okay, now I'm going to change directly here. So if I have a digit like this, 2, 3 and 4, and here also 2, 3 and 4. In this case, what will happen? So I will get my L is D, E, F, and now I'm calling for D. In this time my digit is 2, 3, 4. My input is A plus D, AD, and index will be 2. This time what will be the base case? Now digits is at 3, but it's 2, so no base case. And now L is at 4, we have GHI. GHI. So now my loop will going to be run first for G. Again calling the base case. 2, 3, 4, A, D, G. And now 3, but this time run. So we will say. So by doing this, hopefully it will work. So this is a complete solution. Now we can discuss about the time complexity. So in this case, if we see 3 branches, then when we have 2, 3, it's going to be 3 and then 9. And if I have 2, 3, 4, then it's going to be 27. So it look like the 3 powers 1, 3 power 2, 3 is a 9, 3 power 3. Okay, so we can understand, okay, this is most likely 3 power, but big O is means the worst case, and in a worst case we remember it's 4. So for example, I have an input in which we have 7, 9, 7, 9, 7, 9, or maybe only 7. So in that case, what will happen? We have 4 branches. So in a worst case scenario, I can say our big O of will be 4 power n. N means number of digits. So if I have only one digit, so it means 4 in a worst case. If I have 2 digits, it means 4 power 2, 16. But there is a catch. So if you see this operation, minimum in case of a Kotlin or Java, as per my knowledge, it's a operation, or it's an AND operation. AND operation means in Java, under the hood, string is immutable, so there is a copy of this S and then it will append, and then there is a new string. So from that perspective, in lenient terms, I can say it's not 4 power n. It's like, we know if it's a nested loop kind of, so it's a kind of a nested loop, it will be 4 power 2 power n, or we can say it's 16 of n. But if you think I'm wrong, please give a comment. Okay, then can we improve this? And not from the time perspective, we if you have something like this kind of a code, the tree, you can always improve. How? So in this case, I can say, okay, I'm not sending a string, I will send a string builder. So in that case, what will happen? My output will be string builder and index 0. This S now will be SB, this will be SB, this will be SB dot toString. And SB dot toString, you need to remember it's a N operation. And in this case, what will be the change here? So as we know, I'm going to say, okay, string builder dot append ch and send SB. So still same. Every time I will come, I will append the value, and as per my knowledge, sp dot append for the string buffer or string builder, I think so both, it's a big of one operation if I'm not wrong, except if you are crossing the limit and the capacity, then it will be a big of n. But for now, for this code, it's big of one. And then in case of a recursion, once you are going down, so I am here, then I will go here and assume this is not there. So from here, when I am coming back, I need to make my input correct, because currently it's AD. So once I am going back, if I am not going to remove the last character D, next time I will have a AD and E. So for that, delete last character, or there will be DE, delete at character I think the API is delete character at and my index. So that index will be my SB dot length minus 1. So the last character basically. So in this case, what will happen? Big of 1, and simply here we are doing a big O of n. So what will be the improvement in that case? The worst case is still there, 4 power n, but in this case, the deletion and the append, I'm assuming is a big O of 1, because I'm not able to see the code inside of JDK due to the abstraction. But in this case, if I assume this is big of 1, so we have total 4 power n due to the combination, and then we have a big O of n for every completion of a base case. So in that case, and this will run how many times? It will run the number of digits, how many times like if I have 1, so this is big O 4 power n by putting the string builder, and this is before, as per my knowledge, 4 power 2 power square due to the append operation. Then in this case, if I have only 1, so 4 power 1 and 1, it's 4, because it's been called. If I have 2, 16 multiplied by 2, 32, and in this case 16 power 2 still, but once you will go above that 3, you will see the difference. So this will be better than this one. Now come back to the space complexity. So space complexity is always a confusion. Sometimes we don't care about the output. In that case, if you can confirm also with the interviewer, like I need to take care of this as, or it's like output is a kind of, there is no need. So in case if he agreed with you, okay, output is like, it's okay, we only need to take care of the space which is used in the processing of the algorithm. In that case, this map is always a big O of 1, because we are not going to change and it's independent from the input. And then we will go maximum in a stack is this. So for example, when I have a 1 digit length of 1, I go maximum is 1. When I have 2 digits, we will go maximum of 2. So we can say it's a big O of n, and n is a number of digits. So in in worst case, then like it's always big O of n. That will be our space. And if you are going to calculate also the answer, then it's a different story. Then big O of n, and also our answers are a combination, which means it's going to save in a worst case 4 power n, so it will come back to the same, like you need to multiply with the 4 power n multiply by n. So this n is for the space, and the 4 power n, basically you are going to use this, the total number of combinations you are going to get. For that you have that space.